So thank you all for coming. Hope you all had a good conference so far. I know this is the last day. I actually stayed up until maybe, I don't know, 5 a.m. last night because I'm actually from New York and had really, really bad jet lag. So if I had coffee, that would be great. But that's me. I'm a developer advocate from Google. I actually work with the Google Cloud Platform. And yeah, I'm from New York City. It's my first time in Poland, which is wonderful. I love to travel. I also like to take photographs, and that's actually me. That's my photo, I swear, that's me. I'm probably the only speaker who doesn't use a real photo for my profile. I'm probably the only person who has a camera in front of my face. The reason I'm doing that is just so that I'm actually easily replaceable. So you never know if it's really me here or not. Yeah. That's my Twitter. So part of my job is actually to bring some of the greatest and latest technology to all the developers. And I love to talk with all of the developers about what you're doing and your experiences, especially your experiences in the cloud, whether it's Google or not, it doesn't matter. I love to learn what you're doing. So if you can, talk to me afterwards, or just talk to me on Twitter, or find me on email, whatever. I love to chat. So like I said, before Google, hey, I think I spelled something wrong. All right, before, I've been with Google for about 1.5 years, and before Google, I had been a developer for a while, and always been doing architecture stuff. Like I said, I love to travel. This is actually myself holding a compass in the middle of the desert. Now, I tell this story every time, but I don't have so much time today. But just know, actually, I was walking in the desert for about 4 hours in this specific direction, southwest direction, in order to find an oasis in the middle of the desert so I can actually spend the night. I was actually backpacking with this very backpack here in Asia for about 4 months, and I didn't have a place to stay in China, in northern China, so I actually had to do this. But, talk to me afterwards. But, you can also find my photographs on Flickr, which is really, really awesome. I like to take photos. So, all right, let's get started. So let me just do a very, very quick survey. As you all know, this talk is about everything that you ever dreamed of, which is Spring Boot. How many people saw the beautiful Spring talk? Yeah, very cool. It's awesome. It's one of those talks that changed my life. How many people actually seen a bunch of microservices talks already? Yeah, some. Yeah, well, good. So I think there are about 3 or 4 sessions on the very first day of this conference. So I hope some of you already caught up on the whole microservices stuff. And finally, how many of you are Java developers? All right, I'm in the right place. Good. All right, and who actually has already used containers, just so I don't embarrass myself? Okay, quite a few. All right, cool. So, like I said, microservices, it's definitely a trend that's ongoing right now. We had, at least I counted like 3, 4 sessions in the first day of the conference here, and every conference I go to, there are just a bunch of talks on that already. So I'm not gonna actually go into all of the details about microservices, except when you write it with Spring Boot, which I learned a couple months ago, it's really, really awesome. I love Groovy, and when I actually seeing one of these tweets from Josh Long, who was here earlier this week. When I saw this tweet in one of his conferences, when he actually coded this live, which is like a groovy RESTful service that you can fit in a tweet, that changed my life. Okay, and I always loved Groovy to begin with, and when I saw that, I was like, hey, that's really cool, because I actually came from the architecture background, and I actually architected quite a few J2EE applications, EJB 2.0. Right, and it was different. And now when I see this, it's like, holy wow! Just a couple of lines with a couple of annotations. By the way, without any POM file, without any Maven or Gradle, you can actually deploy this and run this and open up a web server that actually serves the request. So I took that to heart, and I thought that's really awesome. And I actually created something else roughly based on this idea. Which is another very, very awesome Hello World microservice. Of course, you have to start from Hello World. And I made it really awesome. It does a little bit more than just saying hello. So I'll show you that in a second. But the problem with microservices that I have seen so far is that, well, first of all, we are decomposing a lot of these features and things that you want to do into these individual microservices, right? Each microservice is supposed to have only one concern or a couple of concerns that they deal with. What you end up with, is something that SOA actually had seen a lot of time before, is how do you actually manage and deploy all of these services individually? Okay, you'll end up with a bunch of services that you have to maintain. You end up with all of them that you have to deploy somewhere. And every single one of them, you probably need to run more than one instance. Why? Because you don't want a single point of failure, right? It's that simple, right? So if you have like 3 services, you're looking at least maybe 6 instances that you have to execute and run. And how do you actually do that? You can do this manually, right? Individual machines and just provision them like the old ways. Or you could use some kind of tools like Puppet, Ansible, or whatever to actually provision and deploy these jar files or application servers. I saw a talk yesterday just across the room where there's this huge microservices architecture, all designed to serve that kind of purpose. And finally, you have to be able to discover your services when they are deployed. Like, where is the endpoint? How do you figure out where the IP addresses are? What port do you have to hit? That's something that I also have seen a lot of people do with tools like Zookeeper, and there are tons of different tools to do that. But today I'm going to show you something somewhat different, and we'll get to it. So that's my very simple architecture here. It's got a really, really awesome UI. I mean, it's probably the best Hello World UI you've ever seen. I'm not a front-end developer, I'm just saying. And it hits the service behind the scenes. Of course, you can imagine that I'm hitting a number of these different services, or the service could hit another service, doesn't matter. It's pretty conceptual. But no Java application is complete without session replication, of course, for the UI. So I tossed that in there. And I'm actually using Spring Boot with Redis as the session replication backend. Okay, so that's very simple. How many people have some architecture like that, very similarly to it? No? Well, yeah, some, maybe. Yeah, so probably more complicated, I hope. So how do you actually deploy it previously? And I actually have done this many, many years ago. I was working in a startup in early 2000s, and we run everything on a single machine. Of course, what could go wrong? Everything can be run on a single machine, including our mail server, Apache server, let's see what else, file server, or whatever. We have everything. All of the applications are running on a single machine. Of course, if the machine goes down, that never happens. So, but the problem is that, well, something do happen, is that sometimes the application actually eats up all of the resources, right? I have seen this happen when, it does happen. I'm sure it's happened to you before. Is somehow in the code there's this infinite loop and it just loops forever. Yeah, it happens, and it just eats up all of the resources of the machine, whether it's CPU or memory, and that's going to affect all of the other applications that's on that machine, right? That's not something that you want to do. Another issue with this kind of approach is specifically you will definitely see it in some of the scripting languages like Python or Perl, where some of the times you deploy your dependencies into the shared libraries. And this happens all the time. I've seen this tons of time before. And different applications may need different dependencies. And what ends up happening is when you're doing your provisioning and deployment into the virtual machines or into your physical machines, they overwrite each other. And you just don't know what version you're supposed to use. Now, we're all Java developers here. I am assuming that never happened to us, right? Because we have, well, nicely packaged WAR files and stuff like that. And finally, we are pretty tightly coupled to the operating system. I remember laying down applications where, in addition to the application server, right, I also have to make sure I have the right version of the JVM. I need to have the right version of the Linux kernel, and everything else has to be just right. And all of the native libraries has to be just right. And then you put your application on top of that. So there's a pretty high coupling there. Now, in the Java world, there are a couple of things that we do. One thing is that, well, we do something very similar to that, which is running multiple JVMs on a single machine, right? I've seen this done a lot. How many people are doing that, multiple JVM in a single machine? Yeah, some of you. And sometimes you run one JVM on a single machine. Yeah. or sometimes you run multiple applications on a single JVM. Do people still do that? Yeah, some do. Yeah, it's okay. Yeah, because I have seen this done a lot. So you deploy multiple WAR files, or I mean, even if you deploy a year file, I mean, technically there are like multiple WAR files or jar files inside. So naturally you're deploying multiple applications in a single JVM. Now, it actually gives you some niceties because your JVM is capped in terms of memory somehow by the heap that you set. Whereas previously here, you don't, right? Because you're not really properly isolated. But you still don't have full isolation here because every application can still be thrashed, and you could still take up all of the resources. In fact, one application, any one of these could have a memory leak somehow and just take up all the heap, right? And your JVM just dies and just brings down your entire application server, and then everything is gone, right? Which is pretty bad. Again, in Java, we don't really have the whole shared library issues, unless if you're using some old class loaders, then you might have those kind of issues. But typically, we don't run into those issues anymore. Another way of thinking about this, like I mentioned before, is potentially running one application in a single JVM. So what you end up in a single virtual machine. What you end up happening is that your physical machine, like my laptop, will probably have multiple virtual machines running in it, and each VM would have laid down the Java JVMs and stuff, and your application server and your application, and you have a number of these things floating around in your managed data centers somehow. But it is somewhat inefficient because, I mean, most of the time, I would say majority of the time is pretty inefficient because how many have you actually booted a virtual machine on your laptop, right? How long does that take to start? It takes maybe 30 seconds to minutes, and if you have to do this multiple times. I actually booted maybe 4 virtual machines on my laptop before, but still that takes a while. But it is inefficient because you are actually rebooting a whole new operating system. You actually have to spend the CPU cycles on the kernel that's actually living within that virtual machine, and all of the memories usages of the operating system is, you have to add it on top of the application that you're running. So it's naturally inefficient in that way. It's also harder to manage because then you end up with all these other machines you have to manage. I mean, they're virtual, but they're still physical there's an operating system running into it. And you have to manage the security, you have to manage provisioning and all the other stuff. Yeah. So how do we actually do that in the new world? Now, how many people had, I see a couple of hands on containers. How many people had actually created containers and used it in running it? Oh, a few. Okay, very cool. So for containers, it's a new way of packaging things. To me, containers, there are twofolds. One is that it is a format where you can put all of your dependencies, put your application, put your application server or whatever that you need, package them into this nice package, like into this one file. Then you can ship and deploy that. And the other part of it is execution. So you can actually run containers, and they can be running in this isolated manner so that within the container, you get isolation in terms of resource, which is how much memory you can use or how much CPU you can use. And also, in some way, security. And it actually has its own view of the container itself. So let me go through that very quickly. So it is relatively lightweight. Why? Because you're actually not rerunning another operating system within a virtual machine. The way I would, grossly summarize container is, which is I'm going to regret saying it, but the best way to think about it is that it's almost like a virtual machine, but it is not. It is not, because you don't have to boot it. Like, there's no operating system that needs to be booted within a container. It just runs as an existing process in your existing operating system. Okay. And so it can actually start up in seconds rather than, say, 30 seconds or more, because it doesn't have to reboot the kernel or anything like that. So it's relatively lightweight. What that means is that when the container starts, you're not taking up additional cycles to start the virtual machine, and you're not actually spending additional memory to run your process either. It offers you pretty good process isolation so that in case that the application within the container is misbehaving, that is taking up all of the CPU cycles, but that's okay because it's running in that container where the CPUs may be only assigned, say, 20% of your CPUs. So from within the container, when the application is taking up 100% of CPU usage, that's only from its own view. From the physical machine's point of view, that process is only maybe taking up 25% of the entire CPU. So whatever happens in that container stays there. It doesn't trickle down and affect other containers. So that's kind of nice. I'm going to go later SSH into one of these containers, and I'll show you that it actually can see its own network interface. It can actually have its own dedicated IP address, which is separate from your physical IP address here. And it actually has its own view of the file system. What that means is that within the container, you can do whatever you want with the file system, and it will just be kept locally to that container. And another container or your host machine will not see any of those changes unless if you're in that container namespace. So a way to think about container images to me is, in the old days when we actually had these static binary files, okay, where you compile the static binary files and then you can just give it to somebody and say, hey, can you run this on your machine? And of course they can because they're statically linked, so they don't have to install any additional dependencies. Well, container images are very, very similar in that concept. Why? Because in the image, you have all of the dependencies, all of the binaries that you need to run your application. Now, again, if you think all your application needs is the jar file, that's not complete, right? Because you need all the other things that go along with running that jar file as well. So to me, the container image is like static binary. And what does that mean? That means that you can take that image and you can ship it and run it in any of the supported environments. So it's something that Java developers had a long wish for, which I think we got pretty far, which is to be able to write once, right, and run anywhere. Okay, how many are able to do that? Write once and run anywhere? No, yeah, maybe a couple. Okay, yeah. So I think I personally feel that container is another way of doing this in a more generic way, where you can actually write once in any of the languages, not just Java, but you can do it with scripting languages as well, and package them up with all of the dependencies that you ever need to run your application. And then you can ship it, you can run it in the cloud, you can run it on the Google Cloud, you can run it on other people's cloud, or you can run it on your local machine, you can run it in your own virtual machine, it doesn't matter, because everything that you ever need is contained within the container, okay? So write once and run everywhere. And in addition to that, I mean, how many people actually had this experience? I had this quite a few times. There's a bug in production, okay? And you get the call, hey, there's a bug in production. I don't know what's wrong. And then you go to staging, everything's okay. Yeah. and then you go to your own laptop, everything's fine too. But why? Why is that happening? Well, most of the time, there's like a configuration issue between your environments, right? How many people had that happen to you? Yeah, okay, that more people. Okay, I feel safer now. Yeah, it happens all the time. And what do you actually find when you find these bugs? I would say 80% of the time is environmental issues, whether it's the wrong version of something, or wrong version of the binary, wrong version of the configuration, or whatever. The way that containers work is that you will be able to package everything into this image, everything that you ever need to run it. Of course, if you misconfigure your environmental variables, like where you connect to your database, it's not going to work, right? But you're pretty much confident that the image is going to be the same no matter where you run it. It's going to have the same underlying operating system base image. It's going to have the same Java versions. It's going to have the same everything that you say that the container should have. Okay, so that you can actually do and deploy this in different environments, and more than likely you're going to be able to reduce what we just saw earlier. Okay. So let's containerize. Since a lot of people hasn't seen how container works and or being able to run a container, I'm actually going to do this and show you how this is done. And there are a couple of options to containerize in Java application. So let me get right to it. How many people use Maven? All right. Gradle? Okay, cool. Docker? Oh, quite a few. All right. So let me get to it. So here I have my awesome Hello World application. Can you guys see it? Yes? Okay. So that's my Hello World application, my microservice. As you can see, it does a lot more than just saying hi. It actually also say hi from the host name and the version. Yeah, and that's important because we're going to see it later when this is running. I mean, it is important to version your microservices, just so you know. And to run this in Spring Boot, the easy way is, of course, to Spring run. And if I do this, I can run this locally. And there it goes. Yay. And it starts up relatively quickly, which is awesome for a microservice. And I can actually go hit it. Whoop. Let me go reload. No, that's not the one. Hello, DevOps. All right. So that's all it returns. Yeah, it returns a JSON payload. Okay. So I'm gonna consume this later. But that's running locally on my machine. How do I actually containerize it so I can ship it anywhere and run it everywhere, along with the JVM that I want to run with? Okay. So there are 3 ways of doing this. The first way, of course, is the most straightforward way, which is to write a Docker file. Now, a Docker file is a definition file where you can tell Docker container how to actually package your image. Every single line here is going to be executed in a sequential order. So imagine that you are setting this up yourself on your local machine where you have to set up, say, a Spring Boot environment. You can actually write those instructions in a Docker file, so it's highly reproducible by whoever is using it. And once you have to package this up, then that binary file will have all the binaries that you specify here. Everything that you run here will be in the same state, and you can ship it to different service providers or different machines to execute. Now here in the Docker file, the very first line is actually a from statement. So here I'm actually saying that, well, since this is a Java application, I'm going to use somebody else's base image that has Java pre-installed. Okay, and I'm running Java 8 here. You can also do something like this. You can do, say, you can run Debian and colon Wheezy, so you can basically use a Debian base image. But if you do it, then you have to do something like apt update and apt get install Java or JDK, whatever, and then you have to install everything yourself. But if you look at it, it's the same commands that you would otherwise run on your own machine to set up your environment. Okay, so in this very specific example, I'm using the Java 8 image, so I don't have to worry about the Java underlying Java JVM because that will be provided by the image. And check this out. This is GVM tool. So I'm installing GVM tool. I'm using GVM tool to install Spring Boot and Groovy. And the instruction is actually here. It's pretty straightforward. You do a curl get get GVM-tool.net, and then you run it through Bash, and then you can do GVM install Groovy and so on and so forth. So I'm doing exactly the same thing here in the Docker file. So I'm going to say curl and get GVM tool and run it through Bash, right? Exactly what you would do on your local machine, and then run the GVM install, and that's it. And in the end, I'm going to add my Groovy file into this container image by using the add statement. And I'm going to expose the port 8080, which is pretty straightforward. And finally, I'm going to run Spring Boot by issuing the same command that you otherwise run on your machine as well. Now, a big tip here is that when you run things in the container with, say, Tomcat, make sure you have this the last thing right here with -d Java security EGD thingy. Otherwise, it will probably never start. It will start in like 10, 20 minutes. It will be very slow. Okay, so having this, then I can do docker build t my container and dot, and that's going to go ahead and interpret the Docker file and go through all of the steps. Now, because I have done this before, so it's very quick because everything is cached locally. But if you do this for the very first time, it's actually going to go out and fetch everything that you need, put them into a container image. And then I can go ahead and say Docker images. Oh, sorry. Less. There we go. Ah, there it is, my container. So I can go ahead and run it. So another tip here is when you run the container, if you're just testing it, run it with the -ti, so you can actually kill it relatively easily. So here we go. So I'm going to run docker run ti my container. And what this is going to do is basically, just as if you're running this on your local machine, it's going to do spring run, resolving the dependencies, and there it is. So this is actually running inside the container. How do I know that? Well, if I go to another screen here, I do a docker ps, you can see that this is a container that's running, and the command line that's being run. And I can go ahead and hit this here. Oh, sorry, I did one thing incorrectly. I forgot to map the port, so let me do one more. So port 8080, so I want to expose the port. That's also important. And let me try that again. Okay. Yay. So that's actually running in Docker as a Docker container. Now, for those of you who had used containers before, are you using boot to Docker? Yeah. Who's using boot to Docker? Yeah. Or just Docker on Linux? Anyone? No. Yeah. Some. I'm actually using Docker Machine. Anybody ever used Docker Machine? No, never seen it. Docker Machine is really cool. It's another tool from Docker, and you can actually create a Docker server on a cloud provider or locally. So you can actually use Docker Machine to provision, say, a Docker server directly on Google Cloud Platform or on other service providers. Now, the benefit of doing that, to me at the very least, is that, well, it's very, very fast to download things, because every image that you download could be hundreds of megabytes big. So if you are actually running your Docker server on, say, a cloud provider, you can download those images very, very quickly. Not only that, when you're pushing the images to a repository, you also are using the provider's very big bandwidth network to do that. So you don't have to do it from your own laptop or your own network. Okay. Now, the other options of deploying the service is, because I saw most of the people doing Maven, so there's actually a Maven plugin made by Spotify right here. So you can actually use a Maven plugin, put it in the pom.xml, and you can specify the base images that you want to use, which is right here. I'm going to put it on the top. You can specify the name of the image, which I did before, which I coded my container, but I'm calling it something else. In fact, you can use, of course, all the Maven variables as well. And then you can specify the entry point, which is how you are going to start your application. So with that, then what you can actually do is you can just simply do Maven Docker build. And that's going to go ahead, well, assuming you have packaged your application already, that's going to go ahead and generate the Docker file for you, which is really awesome. And then with all of those arguments how you passed in, it's going to create a container image based on those information. So there it is. So very easy to use. If you're using Maven, this is pretty nice. It's one of the best plugins I've found so far. And now it actually built the image, and I can, of course, run it as well. So I'm not going to do that, but I can just go ahead and run it. Okay. What's even nicer is that you can hook it up into your whole lifecycle. So, for example, if you want to build it in the image whenever that you do a package build, then you can just hook it into the phase here. Another thing that's pretty nice about this is that every pom.xml has the version element, right? So every jar file is versioned. You can also version your container image as well. Okay, and And here I can actually just take the version from the project and just tag it directly to the container image. And if I were to do another Docker images, and I'm going to grab gcr.io here. So here's the image I built, and you can actually see that the version I have is 0.1 option 3, because that's the version I put in the pom.xml. So it's a really easy and nice way for you to build your images directly from your Java projects. And I'm assuming you can do very similar things in Gradle as well. Okay. And finally, if you love Spring Boot and Groovy as much as I do, I have a third option, which is I actually built a Docker file. I hosted it on Docker Hub. So remember the base image that I used, like from Java 8? Well, you can actually do something for Groovy as well. You can just say from, well, it's a little long, but from my repository, and do a Spring Boot, and then the version of that. And the short form of this is just do unbuild. And that's pretty easy to do. Now, and this is all you need in Docker file to run a Groovy Spring Boot application to create that image. You don't even need Groovy installed on your local machine to do this. And what this is going to do is it's going to copy all the files into that. It's going to create a new container based on that image. Okay? And then it's going to copy your Groovy file into it. And then during the container build time, when you're creating the image, it's going to go ahead and create a jar file directly when you're building the image. Okay? So when you're deploying the image, it actually has the jar file pre-compiled, so you don't have to recompile them later. Another benefit of doing this is that the dependencies don't have to be re-downloaded over and over again. And it's also a lot simpler to use. You just do that, and you can do, again, Docker build and test. Nope. Here we go. And that's it. So it's going to do everything exactly the same way, except that when you're building the image, it's going to go ahead and do the compilation as well and creating that jar file for you. Okay. So I think we went through all of these things, and now I have to run it. Now remember, my architecture is really, I have the UI, I have the service, and I have the Redis behind the scenes. Now, if you were to run this on your local machine, again, you have to install every single one of those components. Right? How many people are going to install Redis, right, or MySQL, or whatever that you're using in the backend? How many people are going to get it correctly? I myself had tried to lay down infrastructure before, and we always end up with this huge and long installation documentations on this is what you need to do to get your development environment set up. Okay, and nobody gets it right. It's because they're so long, everybody gets it wrong somehow in the steps. But it's gonna be pretty simple with containers approach, because you are actually documenting exactly how you're going to lay down and configure your environment, right, with all of the underlying dependencies, and so it's very easily reproduced. So I'm going to go ahead and run this, run a couple of things. So remember, I need to run three things. I need to run the microservice itself, I need to run Redis, and then I have to run the GUI, which is actually using the Redis server for session replication. So I have to run three things. And I can do this a number of ways. I'm going to show you the first way, which is I'm going to run the service, and that's pretty long. I'm going to run it with the name, and I'm going to run it with the version 1.0, and that's, oh. One second, let me do that. Well, now I'll just talk through it for now, but I'll show you another way to do this. So what you end up happening is you have to run the microservice itself. Okay, so you do that. Let me go back to the slide for now. Okay. And then you have to run Redis, and rather than installing Redis locally on your own machine, you can just use Docker, again, run a container that actually has Redis pre-installed, which is awesome. You run the microservice, but here's the tricky part. You have to be able to let the UI know how to connect to the Redis server, and you need to let it know how it can actually connect to your microservice. And to do that, when you do it just straight up container ways, you actually have to specify this -- link thing. Okay, so what it's going to do is actually it's going to expose the expose the container endpoints from Redis and also from the service itself, and expose those connection information via the environmental variable. Okay, that's very important to know. So from within the UI, what you can do then is you can read the IP address of the service, read the IP address and the port of Redis directly from the environmental variable. Okay, so it's very configurable. So you don't actually have to physically configure it in your Spring configuration file anymore. You can just read it from the environmental variable. Now that's a lot to do. I just want to show you another thing that you can definitely do and you should definitely do when you're working with containers, which is use Docker Compose. So rather than executing those command lines individually every single time, you can capture your mini development environment directly within a YAML file, which is a Docker Compose YAML file. From this YAML file, you can specify the 3 different containers you want to execute, what images they should be using, and also what ports should they be exposing and link together. Okay, so rather than executing those 3 commands, which are relatively long to remember that I will never do, I can just do something like docker-compose up, and it's going to go ahead and read this file, and it's going to launch all 3 of the things at the same time. Okay, so I'm going to give this a try. So right now it's launching the service, the Redis server, and also the UI. And I think that's done. That's a little bit too quick, so I'm a little scared. So let's go see it. And oh, okay, it works. Awesome, yay. Whew, that worked. So that's my awesome user interface, of course, for the hello world. It can't get any better. But you can see something interesting here. You can see the session ID, which is important when we validate session replication. You can also see the host name, and then you can see which service is returning the payload to you. Okay? Cool. So what does this matter? Well, just about everything at Google actually runs in containers. You probably have seen this slide before because we say it a lot of times, probably 2 billion times. But we start 2 billion containers every week, which is quite significant, right? So everything that you ever use, like Google Search, Gmail, YouTube, whatever, they all run within a container environment. How do we manage that? I'm just showing you something on a local laptop here, but when you're running at this scale, right, that's a lot of servers that you have to run all these containers on. And how do you actually do that yourself? Well, at Google, we actually have an internal tool called Borg. Okay, and Borg is our container orchestration tool. So we have all this container technology internally at Google. It's different from what you're using today, but it's pretty similar. And the concept is pretty similar. And we are able to manage, and orchestrate all of these containers by using the tool called Borg. What Borg does is that, at a high level, is that it's going to be able to schedule the containers to run on any one of the machines that's made available to us. Okay, so we have like so many servers, I don't even know how many they are. If you need to run a container, run an application, right, you don't physically and say, I need to run it on that specific machine. No, you actually just say, hey, go and find a place where I can run this and just run this for me. Okay, and so we actually drew up on that concept, and we made something called Kubernetes, which is an open source project that's drawn upon a lot of the concepts and the experiences that we have had managing containers from within Google. And it's an open source project that's written in Go. It's really a container orchestrator. How many people have heard about Kubernetes before? Yeah, very cool. And some of you may even have seen this in action in the earlier sessions. I'm going to show you something similar, but hopefully more sophisticated in a way for DevOps. So what does it actually do? In Kubernetes, there are two things that you have to run. One is a Kubernetes Master, which is the thing that actually oversees all of the nodes. On every single node, there is a kubelet, which the Kubernetes Master talks to figure out, well, how much resources do you have available? And if you do have that kind of resource, go ahead and run something for me. Okay, so it's exactly very similar concept on how we actually manage containers within Google. And what I can actually do then is, I can say, I got 3 containers I have to execute. I got the Redis container, I have the service container, I have the UI containers. And Kubernetes, why don't you just go ahead and figure out where to run this in my cluster of machines, okay? So in a way, if the Docker images are static binaries, okay? And the way you run these binaries is based on, by using Docker run, so they become a process, then Kubernetes really is just a way for you to schedule where to run those processes. And it's actually, you can think about it as a distributed scheduler, okay? Like a scheduler on your laptop, right? It's deciding how to run your application and trying to figure out what resources to take within that machine. Kubernetes is, going to be doing that for all of the computers that's made available in the Kubernetes cluster. So in a way, you can actually think that all of the machines that you have in your data center through the lens of Kubernetes as a single machine. Okay, that's a very powerful concept to remember, because what that also means is that all of the resources that you have in your cluster is made available to Kubernetes to run your applications. They are seen as a single thing that you can actually use and consume. So you don't have to physically go and decide, oh, I need to run it on machine number 001 or 002. You don't have to do that anymore. You just say, go ahead and find a place for me to run it. It just does it for you. Okay. And it's an open source project. It's on version 0.19, which happens to be a release candidate. They're furiously working towards the 1.0 release. Every time I check, do this talk, the number of contributors go up, and so on and so forth. We have quite a few partners that's actually using this technology or working on this technology, including like Pivotal, Red Hat, SaltStack, Mesosphere, and the list goes on. Okay. And before I get into actually how that works and also how I can actually deploy my microservice into Kubernetes, I need to go through some of the basic concepts. And these are very, very important concepts that you have to remember in order to kind of navigate yourself within the Kubernetes world. The first concept here is called pods. Now, we've been talking about containers for the past 20 minutes or so. What is pod? Well, pod is really just a collection of containers. Pod is the atomic unit that Kubernetes can manage. Now, that's usually a hard concept to grasp because I always thought container is the atomic unit that we need to manage, right? But not so in Kubernetes. In Kubernetes, pod is the atomic unit that we can manage. And pod is a list of or a group of containers that have to live and die together, okay? What does that mean? What kind of use case can you think about that actually fits our use case? Well, so imagine if you have a web application and you need to collect, or a Java application, right? And you have to collect statistics from, say, GMX trends or something else. And you have to actively pull the metrics from GMX, right? Then you need to run like a log collector or like a metrics collector. So those two things will probably need to live and die together, okay? So in a pod, you can actually say, okay, in this pod, I need to run the application. I also need to run the collector as well. And they will get started together. They will die together. Not only that, they also share the same IP address as well. So you can talk to other services or other components within the pod very, very easily. They also are all running scheduled onto the same physical machine as well. So for that, you can actually potentially share the volume, share the file system between them. Now, every pod, like I said, has a IP address. And that's really important, especially in Java, because sometimes we do have these clustering technologies that we need to talk to each individual nodes independently from each other, right? And each pod actually has an IP address. And not only that, when we have multiple machines that has pods running within it, they are all navigable from one pod to the other. You can jump through machines to the pod's private IP address. Now, that's actually really hard to do if you try this yourself. Why? Because imagine if my machine here has a virtual machine here with a private IP that only I can get to, and somebody else has another laptop there with their own virtual machine. How can I actually talk from my virtual machine to their virtual machine? Right? You actually have to set up IP tables and routing rules in order for me to see the IP address and being able to be routed to it. So Kubernetes actually do this behind the scenes for you. So you don't have to worry about it. Basically, if you start a pod, you get an IP, and you can talk to other pods. It's really easy to do. Another thing you have to remember is labels. Okay, everything in Kubernetes has labels. Pods and other things I'm going to go through has labels. It's basically name and value pair. You can have any name, and you can have any value. Okay, you decide on what you want to do with the labels. I'll show you a use case later, but you can actually do whatever you want here. The use cases are something like, well, I need a label to say the environment is production or staging. Or I can say, is the pod a good pod or a bad pod? It doesn't matter. You can say whatever you want here. You can also say the version is 1.0 or the version is 1.1. So we'll see a use case of that. So here we actually have the pod here. We have two different labels. We have the version is 1.0, and the type is frontend because they're serving web requests. And you can see within the pod, we have multiple containers running here, which is the application and potentially the log collector. And then we have the concept of replication controller. What is that? Well, it's basically a way for you to start pods and replicating it multiple times. Okay, so here I can say replication controller, I need 2 pods of this type, and it's going to go ahead and start it for you. And if you tell the replication controller that I just need 1, it's going to take away 1. Okay, more than that, replication controller constantly checks the state of the pods that's running. So if you tell the replication controller that you need 4 instances running at any given time, like your web servers, and it's going to check periodically that, hey, how many instances do you have right now? How many pods do I have that matches this condition? And, oh, it's 4. OK, that's fine. I'm not going to do anything. But disaster strikes. I don't know if this ever happens to you. Somebody pulls the power cable. I don't know, mouse running around eating up your CPU, whatever that is. Disaster strikes, your machine is gone. Okay, so it took away a number of pods or your containers with it. And now the current state is actually 3. Okay, now the replication controller is going to notice that and say, oh no, I only have 3 running, but I need 4, so I'm going to start another one. Now, even though the original machine is missing, it doesn't matter because it knows which machines are available to it, and just go ahead and do the same thing, find the machine that has the available resources and just schedule it. Okay. And finally, you need a way to consume this pod. Now, again, imagine if you had the old way where you have individual virtual machines, you have dedicated IP addresses, you need a load balancer in front of it, right? In order to access or to access the website or to access the service. In Kubernetes, there's a very similar concept, which is called correctly named a service. So a service is really, you can think about it as a load balancer that sits in front of the pod that routes the request to the pod that you want to route to. And again, the service, you can have a label, but you can also have what's called a label selector. So in this case, my service will only route to the pod which has the label matching whatever I am selecting. So in this case, this service is only routing traffic to the pod that's the type of front end with the version 1.0. Okay. Or I can do something like this, which is pretty cool. We call this Canary. So we can actually deploy multiple versions of the service into the entire cluster and have some user hitting it and some users don't. And to do that, you need to be able to have the service routing it to all of the different versions that you have deployed. And to do that, all you have to do is to change the selector to say, I don't care about the version, I just want to route it to the type of front end. And regardless of the version of the pod, it's going to be able to route the traffic to it. Okay. So with that, I'm going to show you a little demo, which I built previously. Let me get back here. So the first thing that you need to know is that to run your containers within Kubernetes, you have to make the image available somewhere. Now, whatever I just did was not enough. Okay, whatever I just did, just building that image is not enough. I actually have to push it somewhere to a repository. Okay, so I need to push the image into a repository. It can be on Docker Hub, or it can be on the Google private repository as well. Which has a different prefix, which is gcr.io, but that doesn't matter. So the way that you do that is, let me see here, Docker images. gcr.io. Okay, have about 10 minutes. So if I want to push this into my Google repository, I can just go ahead and do gcloud docker push and the name of the container, and I will just push it into the repository. Once you have it in the repository, then you can actually consume it from Kubernetes. Okay. And to do that, I'm going to start a visualizer, which is pretty cool. Not many people have seen this before. Where am I? Sorry. Okay. That's too big. One more. Okay, cool. And the screen resolution really messed this up, so I'm gonna try that. Can you all see that? Yeah? Okay, cool. So the way that I can actually deploy these containers I just built into Kubernetes can be done like this. Well, first of all, I have to create a definition file on how this deployment can occur. So I'm gonna open up, say, Redis. So I wanna deploy Redis, so I'm going to open up redis.yaml. Okay, so here's the definition file. Let me make this even bigger. So I'm saying that, hey, Redis is a kind of pod, and yada, yada, yada. The two important things here are, well, the image name, which is Redis, and also the port that I want to expose. That's very, very important. And once I have this, I can go ahead and deploy to Kubernetes. And the way I'm going to do that is kubectl create -f and Redis pod. And in the visualizer, you can actually see the pod up and running. Okay, and that's it. That's pretty quick. Yeah, there is no virtual machine booting or anything like that. It's just like that. Okay, and then I'm going to go ahead and start a service because I need other pods to be able to consume this. So imagine if you had like a whole Redis cluster where you have one single master and multiple minions for the writes, then you need like a load balancer in the front. So I'm just gonna put one in the front so other people can consume it. So I'm going to go ahead and create a service, which again is another YAML file that you can define, and there it is. I just started the service. It's very quick today. I don't know why. That's awesome. Maybe it's not working. So remember, every pod has an IP address, and every service has an IP address as well. And the service IP address is more or less stable. It doesn't really change, right? Pod can come and go, and services, the service here that's been defined in Kubernetes is more stable. It's just there, right? You can have a service with no pod. It will just not route it to anywhere, okay? And now I'm going to deploy the microservice. So I have a file for that. And I have version v1. I have multiple versions of that. Okay, so again, the difference here is that there's Replication Controller, and I'm saying that here's the label, version is 1.0. And the important thing again here is that the image I'm pulling, which is with the tag 1.0 and the container port. Okay, so I'm going to do that. kubectl create f. Hello world service controller. Okay, so what this is going to do is going to start, really quick. Now I'm really scared. So, so what this is going to do is going to launch two containers, two pods, each with one containers inside. And as you can see, this is the controller that's constantly checking how many pods I have running. So, whoa, I just clicked on something I'm not supposed to. Okay, so, close out. Okay, so what that means is that if I were to go ahead and say kubectl get pods, grab hello world service, I should be able to see two. Yeah, it's pretty long. And there's number one, right? That's a pod. So I can also do kubectl delete pod. So if something happened to one of the pod, I can delete it. And it goes so fast, the controller actually just restarted another one for me. So you can't really see it. That's a really bad demo because it's too fast. But you know what I mean. Like if I delete that pod, if something happened to it, the controller is going to know it, and it's just gonna go start another one. Okay, now we have the pod. I only have 4 minutes, so I'm going to go ahead and create the service for the microservice. Create F. Whoop. Okay, yay. And finally, I'm going to go ahead and deploy the application itself, the UI, the awesome UI I showed you earlier, the best UI ever. Okay, I'm also starting 2. Everything's going way too fast, so I'm really scared now. And then I'm going to go ahead and do the service as well. So where's the service? So here's the Hello World service. Now this service is a little bit different. It will take a little time to create because I want to be able to hit the UI from the outside world. Everything that we have created here have an internal IP address that's only accessible from within the Google Cloud Platform. Like if you are to SSH into one of these machines, so for example, if I were to SSH into, that's not the one, instances.list. So let me go ahead and SSH into one of these things. So I'm gonna go to one of the nodes. So I can do gcloud compute SSH like that. And I can actually hopefully try to hit this service URL. So it's 103.247.146. Yay, okay, so it's working. Ooh, that's good. Yeah, good to know. All right, so what I'm doing right now is I'm just doing a while loop. Every second I'm going to fetch from the service and just say hi. And as you can see, it's going through the load balancer, and every time I hit it, it could be returning the result from a different pod, right? You can actually see the host name to be different, but they're all version 1.0, which is nice. Okay, and I can actually go to the UI now. Oh, come on, there we go. And hello, and that's all running within Kubernetes. Okay, now in the next 2 minutes, I'm going to hopefully show you something else that's pretty cool, which is something that DevOps guys would love to have. And there are 3 things: rolling updates, where you can actually upgrade your service while with no downtime, and then you can upgrade it by pushing a new service into this whole cluster and then taking away out. Okay, and Kubernetes actually has built-in features to do that. And here's the script to do that, but it's really just one line, so I don't have to remember it. Basically, it does a rolling update. It tells you the Kubernetes what replication controller, which version do you want to take away, and then how long do you have to wait before you start a new pod with the new version and taking away the old one, and then finally the new version of the pod that you want to use. So watch this. This is pretty cool. I'm going to run this script. And hopefully it's not going to be that fast, so you can actually see what's happening behind the scenes. So here I'm upgrading it. So watch the UI here, the visualizer. So now a new replication controller has started, and it started a new pod 2.0. Okay, and after about 5 seconds, it's going to go ahead and take away 1.0. There it goes. So there goes 1. And while this is happening, all the service is still working. And as you can see, the load balancer actually can pick this up and just route it to the right pods. And as you can see, that it was 50-50, right? It's like, because there was just one version 1, one version 2. And now we have 2 version 2s. And again, after that period of time, it's going to take away version 1.0. And that's it. And rolling update, done. Yay. Now, what happens if this is a bad version that you want to roll back? I have like 2 seconds, and I will show you that very quickly. To roll back is very simple, so I'm going to go ahead and do a downgrade. You can downgrade by rolling update as well, or you can just kill all the pods and then just start the new ones. So let me just do that for the purpose of completion. So I'm going to go ahead and do the downgrade. Again, you can see the service is continuous running, and then I have this new replication controller running. Oh, this is actually going to the latest version. And starting the new pod, go to the next version. Another thing you can do very interesting with this is what we call Canary. So if I actually stop it right here, which I should have, when we have like 2 version 1s running in the pod and 1 version 2, we call that Canary because sometimes you are just too scared to get rid of everything and deploy the new version. So if your version can actually run side by side, you can just deploy one of the versions into one pod with a replication controller in the entire mix of all the versions that you have, right? So the user, by chance, will have maybe a 25% chance of hitting the new service. So you can actually validate and making sure that everything works. Okay. And there's a lot of tips and tricks that I learned throughout creating the demo and throughout my experiences with Docker. Unfortunately, I don't think I have time to go through it. But definitely feel free to catch up because there's quite a lot, especially the service discovery, which I didn't get into. Just remember, you can do this via environmental variables or DNS lookup, or you can actually use the API like what I've shown here before. Always test locally, use Docker machine. This is very important. This is one thing you have to remember. If anything else from this talk that you don't remember, this is one thing. Just don't write the log files into your containers. That's just really bad because it might actually just take up all the spaces. Yeah. So there's tons of these things. Just come up afterwards. We have some time. I can go through some of these things with you as well. Now, everything I've done, there are two ways to run Kubernetes. You can run it on your local machine. You can just go to Kubernetes.io, the website, and it will give you this command line. You can just download, and it's going to download like Vagrant and VirtualBox and whatever, and just going to provision everything on your laptop. Or you can do what I do. I like to host everything else elsewhere. So I run Docker machine, and for Kubernetes, I actually run it within Google Container Engine, which is what I've been using today, which has been pretty fast today, which is awesome. And it's just in beta today. So you can actually try this out. If you sign up, you get like $300 credit for 60 days. Okay. So with that, thank you very much. And if you have time, please do take a quick survey about how I did and stuff like that. And if you have questions, feel free to come up. Thanks.